Hi dear students! Welcome sa panibagong episode ng The Bibbo Project at sa episode na ito ay pag-uusapan natin yung topic na tinatawag na microbial growth and microbial control. In this lecture, we're going to specifically focus on the physical and chemical agents for microbial control. At habang pinag-uusapan natin yan, ay maunawaan natin kung ano yung mga factors that causes microbial growth in certain areas and specific conditions. So ano pang inaantay ninyo? Tayo na at makinig sa lecture na ito. Ayaw natin or iniiwasan natin yung tinatawag nating hindi balanse at sobrang pagdami ng populasyon ng mga mikrobyo sa isang lugar o sa isang environment. Actually, hindi lang sa isang environment eh. Di ba? Kagaya nga na sinasabi sa mga lectures ko ng mga nakaraan, kapag ka ang specific number ng bakterya sa ating katawan ay humigit doon sa dapat na number niya, o kaya naman ito ay nalipat sa ibang lugar o ibang parte ng katawan, ito ay hindi na nararapat o hindi ito okay. Now, sa environment, ganun din. If bacteria or other microorganisms that we have discussed so far are going to increase in their population and transfer to places and afflict people, that is going to cause a disease. Pretty much like what happened to the pandemic that we are experiencing right now. So listen to my lecture so that you will understand more about the physical and chemical agents that can help or prevent microbial control. Controlling microorganisms. Physical, chemical, and mechanical methods to destroy or reduce undesirable microbes in a given area is what we call decontamination. So there are different ways. No? It could be physical means, chemical, or mechanical means. The primary targets are microorganisms capable of causing infection or spoilage. And this could be caused by the following: vegetative bacterial cells and then the spores, fungal hyphae and spores or yeast, and protozoan, trophozoites, and cysts. That is also caused by specific types of worms, viruses, and prions. There is relative resistance depending on the kind of microbe that we're dealing with. They're classified into three types of resistance. You have the high resistance, the moderate resistance, and the least resistance. For the high resistance, that is where the prions and other bacterial endospores belong. For the moderate resistance, that's where the Pseudomonas, Mycobacterium tuberculosis, the one that causes tuberculosis, Staphylococcus aureus, and selected protozoan yeast belong. For the least resistance, most bacterial vegetative cells, fungal spores, and hyphae yeast envelope viruses and protozoan trophozoites. As you can see in the image right now, that shows sample bacteria, and the one right below is a sample of the structure of a virus. The yellow-green that you can see there in the image is what we call the rogue conformer. Some terminologies and methods of control are very important to understand, and they are the following: sterilization, which is also known as a process that destroys all viable microbes, including viruses and endospores. Disinfection, a process to destroy vegetative pathogens, not endospores but inanimate objects. Antiseptic, it's a disinfectant applied directly to exposed body surfaces. And sanitation refers to any cleansing technique that mechanically removes microbes. There are several factors that affect the death rate of microorganisms. Number one will be the number of microbes occupying a certain area or a certain environment. Remember that they are all competing for resources, and resources are not limited, they're finite. That's why when these resources runs out, definitely nothing will be there to supply them with the nutrients and food that they need. Nature of microbes and the population. They could be competing with each other depending on the type of microorganisms present in a certain area. Temperature and the acidity of the environment, concentration or dosage of the agent, mode of action of the agent, and the presence of solvents, organic matter, or inhibitors like temperature. There are practical concerns in microbial control. These are the following. Selection of method of control depends on the circumstances. Does the application require sterilization? Because sometimes methods cannot go alone. They can go in pair, maybe multiple methods can be applied. Is the item to be reused? Can the item withstand heat, pressure, radiation, or chemicals? Is the method suitable? Is it the best method to be used in that situation? Will the agent penetrate to the necessary extent? Lastly, is the method cost and labor efficient? And is it safe? We cannot use the same method or a specific method just because we wanted it to. Because there are a number of repercussions. Pwede nito maapektuhan yung ating environment. Say for instance, pag nagkakaroon tayo ng tinatawag na oil spill and we wanted to apply microorganisms in disintegrating particular oil that have scattered in a particular body of water, according to experts, we cannot really have it or use it just because we want to. We have to study what would be the effect of that particular microbe if it's going to be released in the environment, especially right after it had completed its task. That's why careful considerations must be taken into account or must take place. Antimicrobial agents' modes of action. It depends on first the kind of bacteria and second the structure of the microorganism that they're trying to destroy. For instance, cellular targets of physical and chemical agents are, number one, the cell wall, the protective covering of the cell. Particularly, we know that it's not only present in plants, but also in fungi and in bacteria as well. What is the action? As stated here, cell wall becomes fragile and cell lysis, pumuputok, no? It bursts, cell bursting. And some antimicrobial drugs, detergents, and alcohol could be the cause of this. They could be the chemical agents that could destroy the cell wall. The cell membrane loses its integrity. And some of these agents could be detergent or yung mga sabon, no? And many others that belong to the same category. Cellular targets of physical and chemical agents. Protein and nucleic acid synthesis, prevention of replication, transcription, translation, peptide bond formation, protein synthesis, chloramphenicol, ultraviolet radiation, and formaldehyde. And lastly, proteins disrupt or denature the proteins, alcohols, Phenols and acids and heat could be one of, or could be among those that are considered as physical and chemical agents. Some methods of physical control are the following. Heat could be moist and dry. Cold temperatures, later it will be explained. Desiccation or drying, dehydrating rather, radiation, and filtration of bacteria or microorganisms. Mode of action and relative effectiveness of the heat. So in moist heat, lower temperatures and shorter exposure to time leads to coagulation and denaturation of proteins. When proteins are denatured, there are changes in their chemical structure, making them not the type of protein that they used to be anymore. Dry heat, moderate to high temperatures, dehydration alters protein structure, incineration. Now, if you are going to observe the graph that you can see there on your screen, that shows the number of cells added to the population, which is for the growth, and then the number of the cells that survive. There's also the term called thermal depth measurements. Bacterial endospores, most resistant, usually require temperatures above boiling. In the past lectures, we discussed the term endospore. It's a protective covering provided to the bacteria, and it gives the bacteria enough resistance to any particular outside threat. And there are also other two terms that you have to understand. You have the thermal death time, shortest length of time required to kill all test microbes at a specified temperature. The variable there, or the one that you measure, is the time, and the constant is temperature. Whereas on the other part, or the other type, is a thermal death point, lowest temperature required to kill all microbes in a sample in 10 minutes. The variable here, or the one that you measure, is the temperature, and the constant time is 10 minutes. Moist heat methods of disinfection, steam under pressure, that's the sterilization. You also have the use of autoclave. That is, if you have the autoclave in your school, that is 15 psi, correct me for that, or pardon me for that. And then you have 121 degrees Celsius, and that's going to be heated for 10 to 40 minutes time. Steam must reach surface of item being sterilized, and item must not be heat or moisture sensitive. Mode of action leads to denaturation of proteins, destruction of membranes and DNA. And of course, if the genetic material is the one that is already destroyed, the bacteria cannot do any more reproductive function, because it has already been destroyed. And boiling at 100 degrees Celsius for 30 minutes to destroy non-spore forming pathogens. Of course, you're already familiar with the term pasteurization. Heat is applied to kill potential agents of infection and spoilage without destroying the food flavor or value. Usually, what we are used to this is yung sagatas. The one that I mentioned this before, I told you when I was young, my father used to give us milk coming from Carabao milk, and I was wondering why it was so hot. There was steam coming out of the milk, and I just realized then that it was pasteurized pa na, And then you also have nut sterilization, kills non-spore forming pathogens kasi yun lang yung kaya niyang puksain, and lowers overall microbe count. Does not kill endospores or many non-pathogenic microbes. You have the dry heat, or the use of dry heat, using higher temperatures than moist heat, incineration, or that refers to flame, or you're burning something, or electric heating, coil, ignites and reduces microbes and other substances. Dry ovens from 150 to 180 degrees Celsius coagulates proteins. Pag sinabi mong coagulate, there is solidification. Cold microbiostatic slows the growth of microbes. Refrigeration from 0 to 15 degrees Celsius and freezing, used to preserve food, media, and culture. This is basically the reason why we put food in the fridge. There is low temperature, there is an inhibition in the growth of bacteria, not only the growth, but also the activity. Well, of course, growth is part of the activity of the bacteria, right? Desiccation or dehydration, gradual removal of water from cells, leads to metabolic inhibition, not effective microbial control. Many cells retain ability to grow when water is reintroduced. Parang nagiging dormant lang sila. Okay? They may not be active because of the absence of water, but once water is present, they're coming back alive. You have the lyophilization or the freeze-drying preservation. Radiation is also included here. You have two types. You have ionizing and non-ionizing radiation. For the ionizing radiation, deep penetrating power that has sufficient energy to cause electrons to leave their orbit breaks the DNA. So therefore, there is molecular disruption in this type of disinfection. Okay? And as you can see, in the diagram shows the part that is non-ionizing and the part that is ionizing. You have rays, no? Rays or the radiation type that cause incredible health to become healed. Right? This shows the application of ionizing radiation, preserving food with ionizing radiation. So as you can see, I think that's a strawberry here. Right? And then you have the non-ionizing radiation. It's different because there is little penetrating power, so it must be directly exposed. UV light creates pyrimidine dimers, which interfere with replication. Same way, or same, there's prevention of reproduction. Application of non-ionizing radiation, sterilizing air, water, or surfaces. Science investigatory projects of some students makes use of sunlight or the UV ray, all right, to sterilize water, okay, and other objects. You also have filtration, which refers to the physical removal of microbes by passing a gas or liquid through a filter. In addition, it's used to sterilize heat-sensitive liquids and air in hospital isolation units and industrial clean rooms. So as you can observe, this is something that you have to be aware of because most of you, if not all, are going to be working in the hospital. Chemical agents of microbial control, levels of chemical decontamination. You have the high-level germicides, kill endospores, maybe sterilants, devices that are not heat sterilizable and intended to be used in a sterile environment, like body tissues. Right? Intermediate level, kill fungal spores, not endospores, cannot kill endospores, tubercle bacillus, and viruses. Used to disinfect devices that will come in contact with mucous membranes but are not invasive. Next is low level. It eliminates only vegetative bacteria, vegetative fungal cells, and some viruses. Clean surfaces that touch skin but not mucous membranes. Factors that affect germicidal activity of chemicals are the following: nature of the material that is being treated, degree of contamination, time of exposure. Time is really a very important element. Strength and chemical action of the germicide. You have the alcohol, ethyl isopropyl in solutions of 50 to 95%, usually 70%. Right? Act as surfactants, dissolving membrane lipids and coagulating proteins of vegetative bacterial cells and fungi. And they're considered to be intermediate level. Iodine, one of the oldest and most effective antiseptics, works against all bacteria and many endospores, fungi, and viruses. It also alters plasma membranes. Tincture, one examples are tincture, iodine combined with alcohol. You also have iodophore, iodine combined with an organic carrier molecule. And these are still quite effective up until now, but they are less toxic and do not stain as badly. Best example is betadine. Remember, I've been telling you betadine is not only directly applicable to wounds, but also we have betadine gargle right now, right? Hydrogen peroxide produces highly reactive hydroxyl free radicals that damage protein and DNA while also decomposing to oxygen gas, and they are toxic to anaerobes. Antiseptic at low concentrations and sporicidal if a strong solution is used. Disinfectants, quaternary ammonia compounds, or tinatawag din siyang quats, acts as surfactants that alter membrane permeability of some bacteria and fungi. Very low level of decontamination. And lastly, you have detergents and soaps. Soaps are mechanically remove soil and grease containing microbes. Now, dear student, at the end of this presentation, I would like to put emphasis on the importance of cleanliness in our body and in our surrounding. Because if we are going to do that, as you can see, through the action of these disinfectants, detergents, and soap, we can effectively and successfully get rid, or if not get rid, at least lower the population of this bacteria, specifically the pathogenic or the harmful ones, so that we can maintain a safe environment for all of us. And I hope you learned something for today's video and video lesson. Once again, this is Teacher Alfred. If you like or have read or have watched the video, please hit like, subscribe, and maybe share. Maybe you can help others by sharing this video. Thank you very much, and paalam.